Hello, everyone. Welcome to the August session of Dr. Spotfire. I'm your host, Neil Kanungo, and let's go ahead and get started on this session today. Quick announcement, we do have our virtual conference coming up at the end of September in about 2 months. You can find that at now.tipco.com. Make sure you sign up. There is a free track, so if you want some of the content for free, you can find it there. Today's session is a data function jam session. So we are going to jam out today. I'm going to show you lots of R and Python tools. I'm not going to show you the scripts. I'm going to show you how to use these, how you can plug and play them into your analysis, make your life a lot easier. I'm joined today by Colin Gray. Excuse the slide there. It says Andrew Barrage, but it is Colin Gray. And I'm also joined by Sweta Katha. And we're going to do a data function library. And this is Python and R scripts for data analysis. These are examples of some of the functions we're going to show you today. Now, I want to let you know that we are making some community changes, and this is going to move. There's going to be a new link for those of you watching this on YouTube and watching the recording. I'm going to put the link to the new page whenever it's available. And if you are watching this live and you can no longer find this page, just know you can come back to this video and find the link there. And we'll be socializing those over time more. So these are free community data functions. Here's some examples of the data functions that we have available to you. There's data access ones, there's modeling and prediction, there's geospatial data functions, and we're just going to blaze right through a lot of these and show you how to use them. And first, I wanted to talk a quick distinction between mods and data functions, because there is a little confusion out there. So mods are different from data functions. Data functions use Python and Tear service. They use they use a Python and Tear engine, and they're meant for mathematical analysis and working with your data. It's a data working framework, some customizations that way. Now mods uses the Spotfire API, the JavaScript API. So it's all JavaScript based. You can plug and play data functions and you can plug and play mods, but they're different. Mods are custom visualizations as well as custom actions and custom actions with JavaScript and automation, things like that you can do. But data functions are more analytical typically, or working with the data for kind of computation purposes. Today, I am going to use this GeoBuilder. There is a free API key that you have access to a month, so you can try some of the things we're going to show today. Not everything's going to use this key, just a few of the geospatial ones. So don't worry if you're not interested in the geo stuff. We also had a question on Twitter. Someone, I'm not going to say his username because that's quite a username. I did talk to him though, and I think it means the captain of a ship going down a certain river. So it's a pretty interesting name. But anyways, this user wanted to know, how do we sort data imported from the data lake into the data canvas? So that's one of the topics I'm going to show today. Let me go ahead and open up Spotfire here. And you can see what I'm going to show are a few different, functions. So this is on the Fremont Bridge in Seattle. There is this bridge here. It's this drawbridge, kind of famous bridge in Seattle, and there are these little bike counters. You'll see one over here, and it counts how many people are crossing the bridge. So to sort data table, so you can sort in a table visualization, but if you want this table sorted in your source, which is really useful if you want to use the last aggregation or different aggregations for various reasons, you might want to sort this. You need to use a data function for that. And so I'm actually going to, this is already in order. So I'm going to just kind of simulate something that I want to be out of order. So I'm going to call this a random number, and I'll just make it the index. And I get a set of seeds. So there we go. Okay. So now there's some random number here. Okay. Index. So the data function flyout here is where I've loaded up a bunch of these data functions that I want to use. if you first need to store them in your library and you hit find items in the library, and then it'll search and you can type out things like sort, and I have the sort data table by date, and I have a general sort data table, and then you can pin it to your FX fly. I already have it pinned, so it's now saying unpin. But when I have it here, now it's going to be in my Spotfire analysis whenever I open up any DXP, and this is synced to the library. So I'm going to type in sort, and I have my data preparation data function, and I hit sort, and it asks me what's my input data that I want to put through, what's my data table with columns to pass through. And that is this data table, my Fremont Bridge bicycles, and my sort column is going to be the value as a string of the sort. So I say index, and that's the name of my column, and then my sort order, if I want true for ascending and false for descending, so I'll say true, and then I'll hit OK. And now I have it, I can do as a new data table, I can replace this existing data table. If I do as a new data table, here's my output data, and it's sorted here now by the index. So that is very quickly and easily how you sort it in your data layer. So the data function is happening after the data layer is loaded, but it can go back and modify the data layer. All right, something else I want to show is a basic smoother. So what you're looking at, these are byte counts as on days and hours here as people are crossing in this bridge. But it's a lot of noisy data. There's a lot of different hours. You can kind of see an overall trend over the year, but there's also trends throughout the day. So let's try a smoother here. And I created a basic smoother. And by the way, let me actually pop this up and let you know that on this data function page, you can go down and all the data functions that we're showing today, you can click these and download these and use these for free. So this is why we're not going through the code, because you can just plug and play these. And that link is in the chat, and I'll put it in the video description as well on YouTube. All right, so basic data smoothing. All right, so a timestamp or index. I'm using my Fremont Bridge bicycles, and I want my date to be my timestamp, my data values. I want this to be, let's say, what columns do I want to smooth? I have an east side, I have a west side, I have a total. Let's do the total. I could do multiple of these. Let's actually just add the east side in just for fun. I said east side, I said total. Those are the columns I want to add smoothers to. And there's a moving average in here. So what moving average I want to do? Well, this time is, these timestamps are on hour level. So if I wanted to do over 10 days, that'd be 24 hours times 10. So 240 is my moving average interval. I'll hit OK. And this is going to compute. All right. And now I want to add this as columns to my Fremont bicycle data. Oops, sorry, as calculated columns. If you want to add them as columns, you need to have a column in there that you can join on, and it's going to do it like a data transfer, data join in your data canvas, or you can add it, and that's useful if you want to do things after the data function. But instead, I'm going to do it as a calculated column, and it's calculated to the east side, exponential moving average, the lowest smoother, the simple moving average, and the super smoother, and it's done the same thing for total. So what I meant by those columns and stuff, so if I add it as a calculated column, it's put all of these at the very last node of my data canvas, right on the data table. If I wanted to do it add as calculated columns, or add as columns, not as calculated columns, it would have added it right here. And then I could have done more actions to my data flow before it gets to the end. But in order to do that, you need to have a column that you can join your data on. So just know that. All right, so now I brought this in. I got east side here. Let me go ahead and make this the total. Okay, so this is the total. And I want to take a look at some of these smoothers. So I'm going to go to properties, and I'm going to go to line connection, no, lines and curves, and I'm going to add a line from column values. Let's go to my Fremont Bridge, date. Let's say my super smoother on total is what I want to show. And I want to give this a different color. Wait, let's see. Yeah, we can't see this. And total super, Fremont Bridge bicycles. Interesting. Interesting. Oh, interesting that's not showing there. Well, that sucks. Let's see. I can also add it this way. Let's take a look at this. There we go. I just added it that way. So this is actually a little bit easier. So total, let's see, we're looking at the total, and let's make that total nice like gray or something, and I think it'll change as soon as I change the column. So there's a low S smoother, and let me add the super smoother, so total super. There's the super smoother, and these are all different smoothing methods, so you don't have to know how to code for these smoothers. Let's try the moving average, and then we'll kind of move on. So this simple moving average there, you don't need to know how all of these smoothers work, but now I'm able to estimate this data a lot better along these very noisy counts. So you're seeing all this data up here, but when you're looking to aggregate and you're looking at across all of the data, this is typically actually the patterns of how it's going throughout the days, throughout the time of year. All right, so that is the smoother. Another one is identifying duplicates. So I'm going to simulate duplicates by, let's say, I'm going to go to my output data here. Let's go to this data table. So this is just that Fremont data from 2017 onwards. I actually have more data available in my original data set. So let me see here, recommended, where's my Fremont data? Okay. Go to demos, data, I got my Fremont Bridge bicycles. I'm gonna hit okay. Yeah, I'm gonna hit okay. Okay, so now I actually have some more data in there. Let's take a look at this on a, let's change this up here. Okay, and let me turn off the colors. Colors, let me make this the date. Okay. So what we have here, let me turn off my line now also. Okay, what we have here is some Fremont data, and if I want to see some duplicates, I'm going to go to identifying duplicates. So I actually have two here. I have a duplicate identification and a remove one. The duplicate identification is just going to flag the duplicates for me. So I have a data table here on Fremont bicycles, and the columns for identification. So if I select columns that I want to find duplicates on, so I have on the east side, I have values like 1, 5, 30, and that's the number of people I've crossed. But I want to find duplicates on dates. So I need to find when there's duplicate rows where there is a date and that same number of people that cross, because that means I already have that information and I want that information. So if I have it on August 2nd, 30 people crossed at 1 p.m. and I have that 3 times, I only want one of those. But I need to look at both of these columns. So we're gonna add both of those columns in, and I'm gonna hit okay. And this is gonna give me a column output. So, oops, actually, let me do that again because I need to do it on the other table. So duplicates, this is the fun of doing it all live. So my data table, columns, and I want to do my output data. This was that extra data table that I created. And so I'm going to do east side, and I'm going to do the date, and I'm going to hit okay. I'm going to hit okay. And then it's going to add as calculate columns to output data. And what that's done is now added a flag for duplicates. Is it true? Is it false? So you'll see if there's any duplicates in there, it will flag it as true and false, and then I can color it this way here. And I actually did this wrong. That's what was happening. what I needed to do here is actually, I apologize, I need to add as rows my Fremont Bridge bicycles. I'll hit OK. And let's do data. And if you need to rerun some of these, you can go. So here's my duplicate. I can hit refresh right there. And it just ran again. And so if I scroll down, I'll see some trues and some falses. And let's go ahead and look at this data. So this is now over more than 2017. I'll color it by my duplicates. And you can see that that area from 2017 onwards was duplicating my original data set. I had that, and my new data set also had that, but my new data set had this information that was not duplicate. So that's all flagged in there. Okay, now let's do some geodata functions. So I have this map. I'm going to make this map big here. And I'm going to zoom into the Fremont neighborhood. This is that Fremont Bridge right there. And I'm going to do a trade area. A trade area is if you have a single point and you can only drive a certain distance, like let's say 5 miles, how much area could you cover if you drove in any direction? And so this is not just like as the crow flies, a perfect circle, a perfect radius. This is actually dependent on the road networks and the geographical boundaries. So I'm going to just pick this one area across the bridge, copy the map coordinates, and I'm going to put it in here. So I created these little input fields for document properties. So you go to File, Document Properties, you can see that I just put that start coordinates in. I also put the GeoBuilder API key in here, so I don't have to type that in each time or copy and paste it. And this is going to actually use that GeoBuilder API key to reach out to the internet, pull in a JSON, and then put it into Spotfire. So let's go ahead and check this out. I'm going to do a trade area. I'm going to type in trade area. Okay, so here I am, and I have my GeoBuilder API key, and I can do a document property input. And I'm going to select this as my API key. I have my GPS coordinates. I'm going to do that as a document property as well, and that's going to be my start coordinates that I just put in. How many miles to travel? Let's just say 2.3 miles. And then let's refresh this automatically, and I'll hit OK. And now this gives me, I get these table outputs. I get a polygon output. I get the coordinates of the center of this. So I'm going to take those two. I'm going to hit OK. And here's that polygon. All you got to do is just drag and drop this right into this. And you can see if I can only cover 2.3 miles based off of where the bridge is and the water is, this is what that shape looks like. So that's pretty gnarly looking right there. If I want to put the center of the trade area where I had my start point, it is where I had my start point, I can indicate that by dragging and dropping that in as a point. And let's format this a little bit so we can see it better. So a shortcut is you can jump right to a layer if you go to that gear icon, and I'm going to go to my trade area polygon settings. Let's make the border thicker. Let's make it the border dark purple. Let's make this more transparent here. And what else do we have? Colors. Let me make this light purple here. So there's my trade area. Make it real light purple. And then I'm also, just for my OCD, I'm going to color this central point so we can see it better. So colors of the central point, I'm going to make this purple size. Let's make this a shape of a diamond, and that size is okay. So that's my central point. That's that trade area. Now, because I had this as refresh automatically, I can just select another location. So I'm going to go here, copy map coordinates, and I'm going to paste that in here. And what that does is it moves that over automatically, and you can see it kind of forming around the geographical boundaries and the road boundaries right there. Now, another one is routing. So if I have a route that I want to put in, or I calculate between a route, there's this calculate travel route. Now, you might remember in a past session, I showed how to build this data function, and I went through all the scripting and how you go to the REST API and the GeoBuilder API, and you pull that data in. This is now totally released and built into this data function. So you can just click this data function, use it. First, I'm going to actually get an end coordinate. So I'm going to go somewhere in Wallingford, and I'm going to paste that as my end coordinate. Now let's go ahead and use this routing one. So I'm going to type in route, calculate travel route. And here, I can refresh the function automatically as well. My API key, I'm going to use document properties. Let's select a property. That's my API key. Great. My starting coordinates, let's use a document property as well. So it's pretty similar to the last one. There's my starting coordinates. ending coordinates. Let's use a document property for here. There's my ending coordinates. Now travel mode, do I want to walk or do I want to drive, vehicle or pedestrian? I'm going to say vehicle. And then my unit system, metric or imperial. Well, I'm in the US, which is one of like 3 countries that uses imperial. So I'll put that in. And then avoid tolls. You want to avoid tolls? No, let's go ahead and take the toll roads and let's take those highways as well. So I've put all that in, and all I do is hit OK. And now I get these different tables. Now, once I add this path to the trade area, I want that to be a new data table. That's my route path. I also have my summary info and itinerary steps. I'm going to show you what all of these are. So I'm going to hit OK. And now I have my route path. I can hit latitude and longitude and just drag and drop this in as points. And there's my path. Now it's a little hard to see, so I'm going to format this as well. Let's zoom in there. My route path settings. Let's do size. Let's remove this. I'm going to show you, I guess, the formatting that you need to do with these data functions. So there's that path. Can't really see it. So I'm going to do colors. Let's just make this a bright red here. And what I can do is a line connection. So draw a separate line. You hit subsets there. Let's put this in the foreground for the line. Let's make it thicker. There's my line. Let's show some arrows on there. And here we go. So, and then now the drawing order. Well, what order does this go? Well, you want to see how it's all chopped up here and messed up? It's because you need to tell it the order is the row number order. Now it's going the right direction and it's connecting each point in the right order. Okay, so that is the route, which is pretty cool. Because I had this all set up with refresh automatically, I can change these start coordinates, and I'll put that in, and it's going to recalculate. There's my new trade area, and then this is my new route. And Colin's going to show you a little bit about how these document properties work. They're kind of global variables that you can use, and he's going to show you that in the next section. But right before we go to Colin, I'm going to show you one more data function. It's something we get requested a lot, and that's reading a CSV from online. So I'm going to create a new page here. We'll just stay in the same DXP. And this is COVID-19 data from Johns Hopkins University. So we have confirmed cases and deaths and recoveries, and then the states. And so if I click on raw here, it's going to pull up this CSV, and this is a link which has CSV in it. So if you have a CSV URL online, you can read this in. I'm just going to go ahead and right click this and copy it. And then let's use my online CSV reader. So CSV, there it is. And here we can see I have a required field, which is my URL. So I'm going to paste that in. And then I have these that are not required. So one's a separator. If you're delimiting by something other than a comma, you can put that in. If it has a header, you can specify that if you need to. If it doesn't have a header, and that way your first row won't be considered a data row if you tell it doesn't have a header. By default, it will assume that it does have a header. And then the number of rows to skip, if your data starts farther down in the table, you can choose that. But I don't need to select any of those. I'm just going to put that URL in, and all I need to do is hit OK. And it's going to create a new data table called CSV data. I'll hit OK, and boom, it already ran that fast. So then I just need to go down to table, and all right, that's my CSV data. So you can see it just brought all this data in from online, confirmed, deaths, recovered, things like that. Now, some of this may not work if your admin has your firewall up and some URLs are blocked. So you might need to talk to your admin about whitelisting some URLs. It just depends on how that's set up and what you're trying to access. So now, with that, I think we're going to just go ahead and hand back to Colin, or hand over to Colin rather. And Colin's going to show you how you can take these data functions and you can put them together to make like a smart application, but also how you can go into these data functions and edit them if you want different functionality and just use them as a template. And he's going to show you new data functions with machine learning and natural language processing. So with that, I won't give away too much more. Colin, you want to say hi and you want to go ahead and show folks what you got worked up?
Yeah, absolutely. Thank you. So yeah, as Neil said, I'm going to show a few more data functions. They're going to be Python data functions. And the theme of the data functions will be again, from this great list of data functions we've got, a lot of them are around doing, say, some machine learning or some more advanced analytics, you know, that type of thing, getting really into data science with Spotfire. So I'm going to show off a few and how we pull them together. So the key thing is here, and one of the great strengths of Spotfire is you can, as Neil's shown, you can have lots of data functions in the same Spotfire app, and they can all be interacting, and they can be passing results to each other. And through that, you can create these flows. So today I'm going to cover the correlation function. A very common thing to do is look at correlation. We're going to look at a little bit of clustering and how to optimize clusters, and a bit of machine learning through random forest. And then we'll even end in a wee bit of NLP. So I'll start off with column correlation, and I'm not going to show how to configure every data function. You know, when you download these data functions, they've got nice descriptions and they've got documentation to help you. But I'll show just a couple to start with. So if you download the column correlation function, it's actually got an example DXP that you can open up and see it working yourself to learn from. So this is an example where I've got a big data set. So if you look at the data set in here, it's a list of fictional insurance type data. There's a lot of columns and a lot of rows. And we can use the column correlation function to quickly analyze correlation, and it uses Python. So I'll run it first, and then I'll just show you the data function working. So again, with Spotfire, you can create these drop downs that populate a document property that can be passed into your Python data function. So say I want to use a Spearman correlation method, I can pick it, click calculate, and now it's running my Python code. So you don't need to know the code at all. You can just plug and play that data function, and when it's ready, you can see a slight shift in the colors and the correlation here, and we've got a nice heat map. So again, just as Neil's been showing, you can go into your flyout. You see I've got all my favorite functions here. I can click column correlation, and it's very easy to configure. You know, I pick my data. So I've got an example table here, but I want to use certain columns, not everything. I can select my columns, you know, and go through this and just pick what I want. The important thing for building apps in Spotfire is using these document properties. So for instance, that method you saw there, where we can have 3 different correlation methods, you could type it in and then it's hard coded effectively in your data function. But a nice way of working is that you use a document property, which is like a global variable in Spotfire. And what I can do is I can select the document property here that I've called select correlation method. And you can see it's got a value as Spearman. There's an optional parameter, so you can just ignore that. I'm going to ignore it for now, but I'll explain how we can use that later. And once we've done that, oops, I didn't actually add my columns. So let me actually add them. OK. Now that OK appears. And then you can click OK, and it runs the data function, and then it's going to present the output. So here we've got as a new table and all these options that, you know, we've been through already, and you can hit OK. So the nice thing about that is you can then drag that on and do these charts, but by creating this drop down here that's linked to that document property you saw before, that gives you the ability to run data functions in different ways, but without having to touch the data function or the code. So I can do this.
This reminds me, Colin, of the session you did, I think it was around this time last year, on building Python applications, data science applications in Spotfire, and that was a really cool one.
Yeah, that's so interesting you say that, because I have that as one example that we can refer back to. So I'll pull that together, and that was a good example. I'll show that
session. I'll put the link to that session in the video description and
brilliant
chat.
So this was a simple column correlation that's, you know, very useful in just general statistics, looking at, you know, relationships or data functions and data science. Another common modeling technique that I'll show you quickly again, and then I'll pull them together into an app, is building a random forest model. So again, this is downloaded off the website, the community, typical community that Neil showed before, and it's got an example DXP that you can, example Spotfire app you can use. So what this does is, again, uses Python to build out a random forest machine learning model. And this is a nice example because it uses typical libraries like sklearn. And what we can do is you can tell it whether you want to do a regression or a classification, and you can tell it what column you want to predict. So for instance, in my dummy insurance data, I might want to predict if someone's going to renew yes or no their policy. So that's a classification problem. But you've got these options here of the different parameters you can set into the Python machine learning model. So for instance, I could change the max depth of my trees. I could change how many trees the model builds itself to do a little bit more. And I can run that random forest. So this is just, again, running your Python data function that you've downloaded. So the nice thing here, again, is you don't need to know the code. You can go into the Python data function, which is this one, and you can configure all those inputs just like we've seen before to use these. And that gives you a nice confusion matrix out here of your results of how many positives, false positive, false negatives, true positive, true negative it got. And it also calculates an F1 score for you. If we changed it to regression, we can then run this as a regression. Even though our numbers are zeros and ones, it will still actually build the machine learning model. So again, you can see how quickly you can explore these different models by using all these data functions. And then it'll come back with a different visual. And just to point out, the visual here is changing automatically with some clever ARM Python scripts that if you download this example, you can see yourself as well and learn from that. So imagine you want to pull that together. So here's an example of pulling those two data functions together. What I've got is effectively a power output of a plant, energy production here, and this is just shown over time, the energy production. We've got a nice Spotfire mod. Spotfire mods are really good for visualizing outputs from data functions. So I've got this sort of spider plot here. But you can see what I've done with the correlation analysis here. I've got my correlation analysis running the exact same data function as before, just running this one. I can do the same things about the technique, but I've added a Spotfire filter and I've added some nice visuals here. So now we've got like a network chart and we can look at the relationships between the different things that we want to predict. And this is good because it lets you explore and pick what you want to actually model with. And again, you can just click to update that. So each time run in Python, and then you can just drag and drop. And again, this is a mod of a network chart, and it's a nice way to visualize correlations in a heat map. The cool thing here is we can take that knowledge. So say we want to say, well, all these columns here, you can see they're all highly correlated, this group of columns, 1 DP, 2, 3, 4, etc. Well, we can then go and move that into the next stage. So I've built a page in Spotfire called build model. So we've done our analysis. And what I can do is I can look at the columns I want to pass into the random forest model, and I can just hand pick what columns I want from this drop down or this selection box. So this again is the same idea that when you put these inputs into Spotfire, you can then pass them as properties into your random forest data function. You can pick the variable to predict. So it's just the same as what I was showing you on this original example. I've got a drop down to pick my variable. The additional things I've done to make this more suitable for this use case, I've just let people select the column inputs automatically. And again, we've got the same types of extra inputs here. So one thing to note with all these models is that we've exposed a lot of the inputs you might want for you, but there's nothing to stop you going in and using these as templates. So for instance, you might say, well, I know that the random forest has another option I'd like to use. So you can download this, use this as a starter template. But if you want, you can go into the code and you can manipulate the code yourself and add new options. So that's something I'll show in a second, just an example of that. But now what I can do, sorry, I didn't mean to click on that. Let's go back to my model here, and I can change these options just as before, and I can hit, build model. And now it's actually building a random forest based upon my settings that I learned from a correlation analysis and passing that into our data function. One interesting thing I've done down here is because it's Python and R, you can actually export the model. So I can reuse this model below, and this is a sort of additional nice thing that you could do and simulate results. So for instance, I could say, well, let's change some data, and clicking this button to actually simulate what would happen if we increased a variable by a certain amount. And here you can see the results. And again, that's this idea of using these data functions as a template. I took that random forest data function and I just used a standard method in Python to dump out the model as a pickle file. So you can keep that model and reuse it in different Spotfire apps. And I've written a new data function here that actually uses that model. It loads that model and then predicts with it to predict new data. So you don't have to stop with the data functions, you can take them further. But they work great out the box and they've got lots of inputs already. And the other option I didn't show in the column correlation, which I'll show now, is quite interesting. The column correlation by default, when I configured it, was just doing it for all columns you pass into that function. But you might want to use an interactive way to change what columns get passed into that function. So this optional parameter that you see here actually allows you to pass in a list of column names. And what it does is it filters the data for you to those columns and only does correlation for those columns. So that's really useful for this story about making something dynamic. So for instance, if I go to my example 2 here, and again, you can download and try it yourself, instead of passing all the columns, I can actually interact and say, these are the columns I'm interested in, now calculate correlation. So what it's doing is it's taking the marking here and it's passing that into the data function. Because in any data function you want, you can actually say, take this, but actually limit it by marking. So, and I can say, and you can even limit it by marking and filtering scheme. So what was happening here is it was taking that table, but only passing the marked rows in yellow into my correlation function. So that way you can make it much more interactive, that people can do things where they can actually, you can have this like a variable importance chart where I can pick the top 10 variables, and then I can pass that forward to correlation analysis. I can pass that forward to a model. And this is the example, Neil, that you mentioned. This is actually the session I did last year about building a regression prediction using F1 simulator data, using TensorFlow. So very like the next session, so definitely attend the next session. And it's all about this story about being very, having these data functions ready to hand, download them, and work with them. So that was random forest. I built some models. We used column correlation with the random forest to learn and improve the model, all just drag and drop data functions from the data function library. Let me quickly show you 2 other ones because it's a very common use case. We've got a k-means clustering. So again, you can download this and we've got an example. And again, it's very simple. You can say how many clusters you want. You can use all these inputs that are the k-means takes, and then you can hit run k-means. And this is using the classic petal data that everybody uses for their clustering examples. And what we can see is the advantage of Spotfire is you can visualize and interact with it really well. You can see this nice split when it finishes. So you can see here, I've got this clear cluster out here in red, and I've got these other clusters. And again, I'm using some mods below. This is a circular tree map just to show different ways of grouping these together. But with clustering again, so this is really great because you can use clustering, for instance, recommender engines, classifying data. You can use it for anomaly detection, all sorts of things, fraud detection. But knowing the clusters to do is really difficult. So one of the other data functions we've published is called the Dunn index. So again, you can download this. But what the Dunn index does, and again, it's a very simple data function, is you can specify a minimum and maximum range of clusters you're willing to accept. So I can say minimum clusters is 2, maximum of 12, the same inputs from before, and then I hit run. Again, this is running a Python data function configured the exact same way through all these inputs as before, these flyouts. But this time what it does is it gives us back a score for what is the best split you can get from your clusters. So people often use elbow plots. So here it's saying the higher the scores, the better. So here it's saying 4 or 5 clusters or even 8 will give you the best differentiation in your data. So again, this is a good example because what can say, well, let's take that information and say, let's try 8 clusters here, and then you build up this way of optimizing it. So this shows like we've published multiple data functions that can be used independently, but again, you can use them in conjunction together to give you a better analysis to really advance your insights that you find. So one very quick sort of real example I did a demonstration of recently was building a product recommender for a retail company. So this is a sort of clothing company here. We've got different clothing brands. And what I did was I used Dunn index up here, so the exact same function that you can download and use yourself. And I let it analyze products that people were buying. And it then tells me, okay, the best clustering you could do is 5 or 11. Now, I think 11 is a lot, so I could just drag this along and say 5. Again, these are all just passed into your data function. And then when I click it, it's running my k-means clustering via Python again. And the nice thing here again is clustering is hard to analyze. There's so many dimensions and ways to look at it. But again, by you running Python or R through Spotfire, you get this ability to be more interactive without having to worry about the code and what charts to use. Because now I've got this really nice interactive way where I can see, this cluster buys a lot of this product and this cluster buys a lot of that. And I can really delve into it and learn about these clusters. So that's using Dunn index with clustering. So again, just an example of how you do that. And one of the interesting things here is I actually have got 2 versions of that same data function. So I think you showed this as well, Neil, but you can have the same data function in multiple times. So here you see I've got 1 marked products as I'm analyzing products and 1 marked recency. I'm analyzing patterns and of buying patterns. And that's good because what I've done is I've actually edited each data function to have a slightly different output. So if you look at the parameters, for instance, of my product, it's outputting a table. But what I did, because of the way my data was for the recency one, it was better to output a column. So if you see the parameters that are output, it's actually outputting a column which is joined onto my existing data. And to do that was just a very simple change in the script to put out a column instead of, and change my output parameter here to be column. Whereas in this one, you'll see my output parameter here as a table.
And just to mention, like, on how Colin did that, if you want to add the same data function multiple times and do different variants of them, you just add the same data function again. You just go that fly out and you go that function, you add it again, and you change the parameters to something else, and that will allow you to then make another variant of it, and you can still go into the script and change it. But yeah, Colin, yeah, please continue.
Yeah, absolutely. And you'll see, for instance, in my original example, you'll see I've got multiple column correlations now because I've ran it multiple times. So you can have it, and then it can interact with different data sets, be configured differently, etc. So we've covered clustering, a really useful tool, how to optimize your clusters, which is something people often struggle with. They use elbow plots, but the Dunn index is really powerful because it takes multiple things in. We've got random forest machine learning, we've got correlation. So one last example which sort of shows pulling it all together, and this ties into the content that Sweater did, which is around natural language processing. So this is really an example of pulling some of the stuff Neil showed, some of the stuff I've been showing, and Sweater's work and NLP examples into one place. This is Airbnb day, and what I've done is I used natural language data function again that you can download, and it prepares the data. It strips out, it can strip out numbers, special characters. It can generate n-grams using different techniques. And again, you just hit go and it will do it all. It takes a few minutes, so I'm not going to spend the time running that. But again, you can analyze this and build this really nice NLP app. So this is looking at reviews in Edinburgh of different Airbnb properties, and it's colored by the price. But what I can do as well, let's look at keywords. Let's look at people who mentioned noise. Maybe we're worried about noise. So I can highlight where keywords and noise were extracted using this data function, mark those properties, and now I can see on the map exactly the properties where noise has been mentioned. So I can see that around the center. Or I could do things like, well, let's look at where people mention something about location. Okay, let's say, well, they mention amazing, awesome, beautiful, really positive messages, best location. Again, we could then highlight this and get an idea. So you can see there's these clusters. Again, you could maybe cluster it of different properties really around this area that gets that positive feedback. So that's just using the NLP. And you can also do sentiment analysis and text extraction that will find things like mention of interesting places or structures. But what I've got here again is I've actually got some geoanalytics. So I'm using a heat map, which again, you can download. And the idea here is that you can then look at the spread of your data, because there's a lot of reviews in this map. So if I go back and just untag this, unmark it, you can't really see the data because there's so many data points. So what we can use is a heat map. And if we turn off the reviews on their own, you can now get a better feel. And this is colored by the results from a sentiment analysis from NLP. And we can change the smoothing of this so it gets a bit more detailed, and we can zoom into particular areas in Edinburgh, for instance, and really learn where the most positive reviews are. So again, this is all using things like run data function automatically. It's using these inputs to change the data, and you can use filters and everything to affect the data that is seen and passed to these data functions. So if I do a filter, I've configured my data function to react to that, and now it will update the heat map, and now you see it's just in one small part of Edinburgh. So hopefully that's giving you an idea of how you can pull these things together. It's all using just those simple techniques that Neil showed at the start and I've shown, and it's just about combining them with your data and then pulling all these visuals together.
Yeah, thanks, Colin. Those are some really great machine learning examples. Thanks for showing us how we can take different data functions and put them all together and make a smart application, make controls and sliders, and even create variants of those data functions and using them just as a start, as a template. I think where you closed was actually a good segue for Sweta. Sweta's been working on NLP projects, natural language processing projects, and she's got a great one on entity extraction, sentiment analysis, n-grams, and so there's these data functions that are available on the TIBCO community page, the TIBCO data function library on the community. But without further ado, I'll hand it over to Sweta so she can tell you a little bit more about it.
So one of the things that we've been kind of working on is some generic natural language processing or NLP related data functions. And the reason for this is, well, first of all, it's very nice now that we can have Python and R data functions directly within Spotfire. But also NLP in and of itself has been, growing over the last couple of decades, and with good reason, because text is one of the most common like modalities or types of data that you see across industries. And so really the idea was to create a couple of data functions that can be used across any type of text or free text. Any type of data analyst or data scientist always starts by, exploring their data. And that's what I kind of want to show today, how we've created a set of generic text functions for EDA on any type of text data. So this is a kind of toolkit that I've created, and it starts off with just a couple of starter functions. So there's going to be 2 NLP functions that we're going to go over today. And one of them is going to show how you can pre-process text and extract certain types of text features called n-grams. And the other one is going to walk through named entity recognition, part of speech tagging, and sentiment tagging. So just to give a quick high level of both of these functions, the first function involves pre-processing text and extracting n-gram features. And what we're going to be working with today is English text specifically. And the data set is these reviews on Edinburgh Airbnb data. So what we're specifically interested in is this column over here called the comments. So they're Airbnb reviews, and there's a variety of things that we might be interested in when it comes to these comments. The first thing that comes off the top of my head is sentiment of how people feel towards their review or their type of stay. And there's other things we can also gather from these comments, as we'll see in a bit. So the first function is pre-processing text and extracting n-gram features. So any type of text data that you're going to work with, or any type of NLP pipeline, always has some type of pre-processing or cleaning. And this typically involves things such as removing stop words, which are words that might not provide a lot of context in semantics. So this could be words like and, the, articles like that. There's also steps such as performing stemming or lemmatization, and these are text normalization tactics. So for example, if you have someone talking about how they did something in the past, like I was here, that could provide the same type of meanings as a sentence like I am here. So being able to normalize verbs such as was and am, verbs such as she biked there or she bikes there. That provides a lot of help when it comes to being able to have a standard format for which the text is in order to run any types of models on it. And once we pre-process or clean the text, then we can go on to do like more things with it. And this is where some of the analysis as well as machine learning components can come in. And what we're going to show here is how we've created this n-gram matrix. So an n-gram is a contiguous sequence of words. So, and often what we're interested in is certain types of n-grams, like unigrams, bigrams, and trigrams. So trigrams, for example, is a contiguous sequence of 3 words that appears across the text and how many times those 3 words might appear. And from these n-grams, we can get some interesting properties, like a matrix that can be used for modeling. We could get key phrases, for example. And lastly, what we want to do is be able to store all these things that we created in order for further use if someone wants to do further modeling. And that's just a high level of the first data function. The second data function is, again, going through named entity recognition, part of speech tagging, and sentiment tagging. And it does all these using this library called, this Python library called Spacy. So Spacy is very common in NLP. And over the last few years, it's been gaining a lot of popularity. And I think it's a great Python library for people who are just starting out with NLP to get more hands-on with. So again, this is just an overview of what the actual DXP looks like. And what's interesting is that we can set up ways for people to just directly go ahead to run these data functions. So again, what you're interested in specifying in order to run these functions are your text column name, some type of identifier that shows how the texts are unique. And again, arguments that have to do with the pre-processing, how is the text going to be read into the data function, how you're interested in cleaning the text, as well as standardizing it. And then we go into more of the n-grams features. And yeah, so this is just an overview of how you can directly call to these data functions and be able to run them just instantly on any type of text data that you want to input in here. And just as in the order of time, I think it's interesting to show what are the results from these data functions before we go into the more technicalities of how it was written. So I mentioned that the first data function, again, it has to do with pre-processing text and extracting n-grams features from it. So these are just a couple of visuals that I put up from the result of that first data function. So again, we're talking about Airbnb reviews, Edinburgh Airbnb reviews. So as I mentioned here, we have the original text, and this was from that comments column that we saw before. And the first step that we do in any NLP pre-processing pipeline, or excuse me, NLP pipeline, is to pre-process our text. So what I thought would be interesting to show here is just how our original text compares with the pre-processed text. So for example, here, you can see that one of the reviews was very short, and it just says there's a comfortable bedroom. And once we run it through our pre-processing pipeline, which involved taking out stop words and normalizing some of the text, we just have comfortable bedroom left. And the same here, we see that a lot of the stop words are removed and just use short and succinct text. And I'm trying to see if we have an example of where like some of the verbs might have been like normalized. Let's see. Yeah, but I mean, as we scroll down, we might be able to see how a lot of these texts in general are just like more succinct now. And that's more succinct now, and that's just better for any model that we choose to run it on. Here, for example, you can see that a lot of special characters, such as the commas, were removed. And once this text is pre-processed again, that's when we run it through our n-grams extraction. So over here on top, you can see how we've extracted different types of n-grams from these pre-processed text. So here what I'm showing is the most frequent n-grams across all the text. So I think we had around 90,000 reviews. And from here, we can see that when we look at the most frequent n-grams, it usually tends to be just like unigrams or one words. So things like great, stay, play, location. And all this tends to make sense, again, if we're just considering like location reviews. And while these are just the most popular across all the documents, we can also look at specifically like bigrams. So common phrases you can think of or common n-grams are like great location, highly recommend, city center. We can also look at our trigrams too, and we can see stuff like would definitely stay, would definitely recommend. So, you know, off the top of our head, this might give a good indication that we're looking at pretty positive reviews overall. And the last thing I would want to mention that we highlighted in this data function is just being able to extract key phrases. So once we've ran or computed our n-grams, one of the things that we do is assign either a TF-IDF, a term frequency, inverse document frequency, or a term frequency score. This is how the n-grams are again calculated. And from these scores, we can actually get key phrases almost. And these key phrases are pretty handy with some tricks in Spotfire in order to filter through our original text and the pre-processed text. So again, we have like for every document, we might want to know what are the top 5 key phrases and then search for those. So that's just like a quick overview again of the first data function, which has to do with pre-processing the text and extracting some features from it. And I did want to go a little bit over the other data function, which has to do more with getting part of speech tags, named entity recognition, and sentiment. And I would categorize all of this as tagging, because what's essentially going on is, well, actually, maybe I should step back a little bit and explain what these are. So named entity recognition is essentially just being able to define being able to tag predefined entities from text. So for example, you might find people's names, locations, etc. And part of speech tagging is more what it sounds like. So it's able to find grammatical tags such as like nouns, adjectives in the text. And lastly, sentiment tagging has what sentiment tagging does here is it finds phrases and assigns some type of polarity, aka like a negative or positive score with it, and also a subjectivity metric, like how objective or non-objective is this phrase. And then we also have overall scores for the document itself. So again, these are done using the Spacey library. And what's going on is that we've loaded a pre-trained English model. And then we've just used that model in order to tag our comments data. And what I'm showing over here is just the actual tags that we found in that 90,000 data set. So here we have the part of speech tags, and we see that, you know, nouns and adjectives are the most common types of words that we're going to see. And when we actually click on them, we can see what are the most common or the top words per a specific part of speech tag. So the types of adjectives that we see in our text data, again, are words like great, clean, comfortable, perfect, which again is pretty nice because maybe it gives us an idea that these are generally like positive reviews. When I look at the named entity recognition tag, one of the most common things again are people's names. And this is also pretty common because you can imagine when you're writing reviews about like your Airbnb location or a hostel location, you might mention your host name. And some other things that are interesting is that we can, you know, look through other categories. So again, since we're working with a specific location data, I thought it'd be interesting to look at the buildings, airports, you know, what else you might find that's mentioned. And you can see a lot of the places such as like Edinburgh Castle, Princess Street, the Royal Mile, locations that are actually in Edinburgh or nearby to be mentioned. And lastly, just an overview of what the sentiment tagging looks like. So I mentioned that the sentiment tagging operates on 2 levels. It operates on a phrase level as well as a document level. So one of the first things that we're interested in is, you know, what is the overall sentiment distribution across all these comments? So the sentiment distribution works as follows, like a more negative score or like a more negative review is rated with a score of -1. And then a more positive review has a score, or a more positive review has a score of 1. So what we see here is kind of like the overall distribution in our text. You can see that most things are here in blue are between 0 to 1. So they're generally like positive comments. And you see that there are actually very few negative comments, although there are some. So what I've done here by through Spotfire's markings is just to highlight some of the negative texts and then looked at what phrases are associated in these texts. And we can see that some of the negative phrases are words like dirty, disappointment, not much more, really poor. They appear like in a more reddish color here compared to, you know, there are some positive comments also in these, but overall, we can see that we can get an idea of like, what's going wrong, or, what was a problem that someone might have mentioned in these reviews. And that's just like easy way again of how we can be able to decipher more about the sentiment that's going on within these reviews. And just to highlight overall that all of this was done using a pre-trained model. So all of this work was completely unsupervised and really just requires us configuring the specific types of parameters that we want to run, and then run it on any type of free text data, English free text data.
All right, everyone. Thank you for joining today's jam session on data functions. Make sure you check out that page. There are a lot of data functions, and we got some more coming on the way. Really cool new feature of Spotfire. Be sure to register for TIPCO now. Again, there is a free track that you can sign up for, and we'll catch you on September 7th, 9 a.m. Pacific for our next live session of Dr. Spotfire. Thanks and take care. Have a good one.